Hello and welcome back to the NACLO Problem Walkthrough series. My name is Nathan Kim and I'll be walking you through today's problem. I competed in NACLO for 3 years from my hometown of Toronto, Ontario, and those 3 years have exposed me to so many wonderful linguistics enthusiasts and problem solvers and invited me into a community to which I'm still indebted today. So I'm hoping that this video will encourage those eligible students watching to register for the forthcoming NACLO contest and enjoy that same experience themselves. This problem, called Pay Attention, comes from the 2020 NACLO Open Round. And it gets its name because it revolves around something called an attention head. If you don't know what that is, don't worry, because this problem is all about introducing this concept and getting you familiar with using it. So the first part of this walkthrough is simply going to give you a little background on what an attention head is and does, and this will all be pretty much parallel to the background included with the problem sheet itself. For our purposes, we can start by imagining an attention head as a small machine that reads in a sentence and rates the relevance of each word in that sentence to every other word, including each word's relevance to itself. But in terms of deciding what about a word is relevant to other words, each attention head actually uses its own unique criteria, and so two different attention heads will often score the same words quite differently. And that is a pretty abstract description, so to show what an attention head looks like in action, here we have fed a small sentence, so the cat sat on the mat, into a real attention head and visualize all the scores it assigns for a particular word, say cat. As you'll notice, most of the connections originating from the word cat have fairly low scores, and so they show up in this kind of paler color. But some words like sat and mat are scored much higher, and so they are connected by relatively darker lines. Overall, from this diagram, we might conclude that sat and mat, at least according to this attention head, have some sort of particular importance to the word cat. However, these relevant scores are only specific to a particular direction. In fact, as you see here, the connection from mat to cat is much more pronounced than the connection from cat to mat that we observed in the slide before. So, in summary, an attention head's outputs can tell us a lot about how it operates, but we just have to be careful about the direction. So, having explained all of the basic functionality of an attention head, I should properly discuss how we use them. To put it simply, attention heads were thought up or designed to be enhancements for what we call language models, which are computational tools which try to understand language and do lots of things with it. Most language models which use attention heads typically use quite a large number of them, enough that they label each one with a unique pair of numbers. In the example before, I've just actually picked out head 1, 1 out of laziness, but from the same model, we can actually pull a head 8, 10 and a head 7, 6. And as I mentioned before, these three heads actually disagree quite a bit on how they rate the different words in the sentence. Naturally, the next question is, what role are attention heads playing in these language models? Or what about them is helpful for understanding language? As it turns out, there are many answers to that question because attention heads can do many things, but one big function, and the one this problem is based on, is that attention heads can really help language models understand a word's meaning given its place in a particular sentence. To explain why doing that is important, I've drawn up a little example here. So here I give you the word play by itself, and I want to know simply just what it means. But exactly because it's by itself, we can't be entirely sure. It could be the type of play that is put on a stage by some actors, or the type of play that is the action performed by these young people in front of a video game console over here. And I'm sure there are many other possibilities that you can think of. But the bottom line is that without any context, we aren't sure which sense is the one that we're looking for. Enclosing this word in a sentence, however, provides exactly the context we need to narrow down our options. For example, if the sentence was, the actors put on a play, then the word actors would clue us into the fact that this play is something, theatrical, something related to the stage. And so it gives us a great surety that this sense of the word play is the former one from before, the theatrical stage play. But if the sentence were, I want to play Monopoly, you would have completely different cues. Now, we have the word monopoly, which through the same kind of word association we saw before, clues us into the other sense of play, the one about video games or board games or things you do for fun. But we also receive context from the phrase want to on a kind of different level. Since we observe that words that follow this phrase want to are most often verbs, we can use it to eliminate for sure the senses of the word play which are nouns, like the stage play sense from before. And so you can also have context provided in this grammatical way as well. And if we follow this logic further, in theory, the meaning of any word can be deduced simply by looking at the context that surrounds it, which is very promising for our goal of understanding language. However, not every word in that sentence gives the most important context all the time. And so if a computer or a language model wanted to perform this task itself, it would need to first identify somehow what other words in that sentence are important to that word and which words are not. And this is where the attention heads come in, because by varying how strongly it scores each word in its relatedness to the target word, it can highlight or attend to exactly those words which provide the most context. This is also why it makes sense that language models need so many attention heads. Because, like I explained in the Monopoly example, different words can provide different context at different levels and in different ways. So if we use a large number of attention heads and delegate each one to a different type of context, then we can bring out those differences as well very clearly. And in this way, the attention head ultimately leaves us with a representation of the sentence that makes it very easy for the language model down the line to know which sense the word is taking. But the best part is, all of this complex behavior can be accomplished without ever having to program a single line of code to tell these attention heads what to do. Because, as it turns out, in the same way that we humans get comfortable with new words when we see them used repeatedly, the attention heads can teach themselves to do their job, provided only that we feed the language model a large set or corpus of real normal sentences to learn from, in the way that we are learning all of the different kinds of plays, all of the different senses of the word play, by reading a bunch of sentences here. There's something very fascinating about that too, and it's that even when we give these attention heads complete control over how they develop, when we go back and investigate what they're trying to do, we see that some of them have taught themselves to carry out some actually very simple and very familiar linguistic tasks that even you and I can recognize. So to illustrate that, let's look at this example provided in the problem introduction, which was generated using this model called BERT. We are given two pieces of information. Under example, we have an English sentence where each of the words are numbered off in order. And under output, we have a series of connections going from one number to another. As it happens, this output comes from running a particular attention head on the example sentence, picking out the most highly scored connections between two words in that sentence, and recording them using the number positions of those words. If we convert numbers to words, we'll see that this attention head strongly connects sister to see, me to see, and book to reading. And in the sentence, if you pay attention, we'll see it saying, I see my sister, but she can't see me because she's reading a book. All three times, it's connecting a verb to the exact thing it's acting on, its direct object. And so in conclusion, this attention head has trained itself to connect direct objects to their verbs. And actually, this entire problem is just a more elaborate version of this discovery process that we did here. So it means looking at some sentences, looking at the output made by some attention heads running on those sentences, and puzzling out the roles that each of those attention heads are playing. And with that, actually, we've covered everything we need to know about attention heads in order to move on with the problem and solve it. So now that we're done with the problem background, we can finally move on to solving the problem itself. And the first part of that process is just to go over what the problem gives you. To start off, you're given a corpus of 7 sentences, each with all of their words numbered off in order, just like in the last example. However, as indicated by a note at the bottom, this time we consider the possessive apostrophe s as a separate word. So as you'll see here, they're written separately and they have their own number. Next, we're given the problem statement itself. In our experiment on the NACLO Web corpus, we ran each of the corpus's sentences through BERT, which is the model from the last example, and recorded the outputs of 4 attention heads, 811, 76, 96, and 54. Unfortunately, due to some extremely sloppy experimental procedure, we don't remember in which order we ran them through the model. In addition, we forgot to record some data. Your job is to fill in the blanks. Note that some blanks may have more than one connection, and some may have none at all. The attention head outputs that this paragraph refers to are located below in this table. And indeed, there are two, problems with this data. First, the sentences are ordered A through G and not 1 through 7, so we don't know how they match up with the ones in the corpus. Second, some of the cells in this table are missing, meaning we just don't know their values. This is different from the cells which say none, which instead is for when we know that there were no strongly scored connections made by that attention head in that sentence. And finally, we are given the two tasks in this problem, which are A, matching the labels A through G to the numbered sentences 1 through 7 we have in the corpus, and B, filling the blank cells in the table, again with one connection, multiple connections, or the word none to signify that there are no connections. At this point, you can feel free to pause the video and try the problem yourself, either by looking back through this video or finding the problem sheet as it appeared on the NACLO contest booklet at nacloweb.org. But otherwise, we're going to move on to actually solving the problem, and the solution looks something like this. So we start by going back to the data table, which I have neatly rearranged here. At first glance, it seems best to start with sentence A, since it's the only one where we know the outputs for all 4 attention heads. And in fact, it is a good place to start, because looking at the output for head 96, it references a 14th and 15th word. And if we go back to the corpus of sentences, there is only one sentence which even has a 14th and 15th word. So we know automatically that sentence A corresponds to sentence 6 in the corpus. Therefore, we can take all of the numbers under sentence A in the data table and replace them with the words from sentence 6, with the result being this. Now, like I suggested in the problem background, we want to work towards figuring out a role for each of these attention heads. And although this one sentence doesn't give us too much evidence, we can start to set up some basic hypotheses. For example, head 8.1 connects A to lot, so we might wonder if 8.11 connects A's to the words after them. 7.6 connects my to exam, so it might be that 7.6 connects possessive pronouns like my or your or maybe their to the things that they possess. 9.6 connects of to fun, so it might be that 9 to 6 connects prepositions like of to their arguments. And we can actually do just the same for head 5.4, although the relationship isn't as immediately obvious as the others. We see that it's connecting it to exam and my to I, but unlike the others, there's no obvious grammatical relationship that works for both of these connections. But what we can do is go back to the corpus data and think about what's connecting these words in the context of the sentence. Like, what does my have to do with I? Well, we can say that I and my are describing the same person, which is me. But what does it have to do with exam? Well, from the sentence, we know that the exam that is difficult is the same as the it that is fun. So these two words are also describing the same thing, which is the exam. So somehow, this head 5.4 is able to detect when two words are referring to the same thing and then connect them. And in addition, it is connecting 5 to 1 and 10 to 7. So it is doing this in a backwards direction, which we'll have to keep in mind later. Formally, in linguistics, we call this relationship co-reference, where both of these co-referent words refer to the same thing. So I'm going to label head 5.4 with that word just so we remember what it does. But you're welcome to label it same thing or whatever other term works for you. There's no need to get stuck on the terminology. And while we're at it, let's label the rest of the columns in the same way. So now we have an initial idea of what all the heads are doing. And in general, the next step should be to look at where a head is being activated in a particular sentence, see if there are any sentences in the corpus with words which fit those activations based on our newfound understanding of what the heads do, and in so doing, try to match the rest of the sentences. There are many equally correct directions you can take here, but for the solution, I'm going to start with head 7.6 in sentence B. We figured that head 7.6 connects possessive pronouns to the possessed object, and in sentence B, those connections are 8 to 9 and 11 to 13. So we need a sentence where words 8 and 11 are possessive pronouns, and 9 and 13 are things that are being owned through those pronouns. A quick look at the corpus should show that sentence 5 is the only one which squarely fits that criteria. And so, just like last time, we can fill in the numbers with words to get a better understanding of the connections being made. Here, actually, there are no surprises. 9.6 follows expectations, connecting a preposition with the words eggs and feet, which it goes with. And 5.6 connects both itses to the platypus, because, of course, when we say its eggs and its feet in that sentence, we're implying of the platypus. And as well, there is a blank in column 8.11, which we could fill right now, but I would prefer to hold off on that until we've gone through all of the data and we're 100% sure about each attention head. From here, all we have to do is to pick another cell, and I'm going to stay in the 7.6 column again, and this time look at sentence F. This time, we need possessive pronouns in positions 1 and 5, and possessed things in positions 2 and 6. And going back to the corpus, we know it must be sentence 1 because no other sentence begins with anything like a possessive pronoun. However, there is something worth noting here. In position 5, it isn't actually technically a possessive pronoun, but the apostrophe s, meaning that the head 7.6 must consider these the same as the regular my, your, its, and so on. But thankfully, it shouldn't cause too much alarm, as both of these words indicate possession and go before a possessed noun. And so again, we fill in the numbers with words, and here there are no surprises. Next, I actually want to draw attention briefly to sentence E. We don't know its activations for head 7.6, so we can't figure it out that way, but we can using head 9 to 6. We just need to find a sentence with a preposition at position 10, pointing towards a noun at position 13. And going back to the corpus, we see that sentence 7 is the only valid option. The preposition into is going with the noun experience. This time, when we fill in the words, however, there are a couple notable points. First of all, 5.4 connects science to linguistics. These words are both nouns and don't have to co-refer by default, like how pronouns like my and its have to refer to a noun previously mentioned in the sentence. But these two words do become co-reference on account of the fact that the sentence links them together explicitly. You'll see that it says linguistics is a science. Secondly, in head 8.11, we are connecting a to science, which is something that we've seen before, but also the to experience. So this must mean that the word the also falls into the same category as a according to this attention head, which also isn't a humongous stretch considering that they are both articles that come before the noun. And with that settled, the next place I want to focus on is again in the 7.6 column for sentence C. We need possessives at positions 4 and 12, and looking at the corpus, we find that although there are multiple sentences with possessives at position 4, sentence 3 is the only one that also has one at position 12. Remembering, of course, that we now count the apostrophe s's along with the possessive pronouns. This time, when we fill in the words for sentence C, we discovered that the word this is also attended to by head 8.11. And we update our idea of what the head does accordingly. Again, we can justify this by the fact that this, in addition to a and the, is a kind of special modifier that comes before nouns. The last sentence we can pick out using data in this table anyways, is sentence D. And here it would be best to use the 9-6 column. So for that, we need prepositions at positions 12 and 13. And looking at the corpus, we find that sentence 2 matches those criteria, connecting word 12, of, to word 13, language, and word 8, into, with word 11, workings. Something that I want to draw attention to is that although inner workings in this sentence is one singular phrase, the word only connects to the word's workings. Because attention heads only connect words to words, when we think about bigger phrases like this, we have to choose only the head or the main word in that phrase for the attention head to connect to. And this will be very important in the second part of the problem, so I'd like to for you to hold on to that thought for now. At any rate, we can fill in the words for sentence D, and that leaves us with only one sentence left unmatched, both in this table and in the corpus. So by elimination, we know automatically that sentence G equals sentence 4. And with all the sentences matched, that concludes the first part of the problem, and we can now move on to the second. The second task in this problem involves filling in the cells marked A through I, and we can simply solve it in that order. For cell A, we need to work out which connections must have been made by 811 in sentence B, or sentence 5. So since head 811 connects words like a, the, this, and so forth with the nouns that they are associated with, we just need to go back to the corpus and find which words can be connected in that way. Going into the sentence 5 in the corpus tells us that there are 2 of those words. The word the at position 1, which goes with the word platypus, and the word at position 4, which goes not with the word strange, but with the word animal, because strange is only modifying the word animal, which is the main word in that phrase. And then we can fill in those answers in the table. But keep in mind that our answers have to be in numbers and not words, the way the table was originally set up. So here we write 1 to 2 and 4 to 6. Next, cell B is under column 9-6 in sentence C, or sentence 3. This attention head, if we recall correctly, connects prepositions to their associated nouns. So going back to the corpus, we start by highlighting all the prepositions. There's one at position 1, at, and about at position 9. That's simple enough. And then we connect them with their arguments. Be careful here not to skim over the sentence and connect at to corporation and about to company just because the phrases at this corporation, about the company makes sense on their own. Reading the sentence properly, of course, would show that at really goes with meaning, at this corporation's meaning, and about really goes with plans. And those 2 phrases, this corporation and the company, are just modifying the words meaning and plans. And when you fill in the numbers for that, it looks like this. Next, cell C is under column 811 in sentence D, or 2. And here, just like sentence A, we go back to the corpus and connect any A's, thes, or thises to their associated nouns. In sentence 2, there is just the word the at position 9, and it connects to workings at position 11. And there you have it in the table. The next missing cell is under head 7-6 in sentence E, or sentence 7. Again, recall that head 7-6 connects possessive words to their possessed nouns, so we go back to the corpus and look for all of the possessives in sentence 7. When you actually do that, though, you'll find that there just are none. And that's fine. We just have to write none in that cell to signify that this head doesn't make any connections in that sentence. Next, we have cell E under head 811 in sentence F, which is also sentence 1. But again, when you actually go back to the corpus and look at sentence 1, you'll find that there is nothing for that attention head to connect. There are no A's or thes or thises or any other words like that. So again, we just answered that question with none. And now all we have to do deal with is sentence G, or sentence 4, and for that we have to fill in the whole row. Starting off with head 811, there is really just one connection that can be made here where the word the matches up with a noun candidate. For head 7-6 as well, we identify just one connection, connecting the two words of the possessive phrase her resume from positions 10 to 11. Third, we have attention head 9-6, which, to jog your memory, connects prepositions to their arguments. There is just one preposition here, which is in at position 1, and it goes with the word July right next to it, because in the sentence we are saying that we are interviewing the candidate in July. So we make one connection from 1 to 2. Finally, we arrive at attention head 5-4, which, to reiterate, connects co-referent words in a backwards direction. This means that we have to look for words in the sentence 4 which refer to the same thing in the context of that sentence. Now, if we read the sentence carefully, we can split it up into two actions. We are interviewing the candidate and we are reviewing her resume. As we understand it, of course, the person whose resume is being reviewed in the second clause is most likely the candidate from the first. So candidate and her are co-referent. So we can't connect her to candidate, noting the direction, or 10 to 7. With all of that filled in, we have answered every question in the problem. And just to put that into context, we've just taken a few sentences combined with the output we get from passing them through 4 attention heads, and not only discovered a unique linguistic task that each attention head has trained itself to perform, but also extrapolated that information to fill parts of this table that were previously incomplete. And I just think it's cool that even for something as abstract or complex or something called an attention head, we were able to do all of that on pen and paper. And of course, to back that up, here are the same answers as they appear on the official NACLO solution booklet for the 2020 Open Round. And indeed, we have answered everything correctly. And that finally brings us to the end of this walkthrough. If you found this problem interesting, we highly encourage you to go to nacloweb.org/practice.php to see all the other problems from past NACLO contests, and to register for the upcoming NACLO contest for free at nacloweb.org/register_student.php. That'll be all from my end. My name is Nathan Kim. Thank you very much for watching.